Alright, for today's lesson, you guys need to look in your workbook, and you need to find the page that says Lesson 2.5, Comparing Rational and Irrational Numbers. There is a number down at the bottom. It does say 26. But up top again, it's Lesson 2.5. Alright, so today we are going to talk about comparing, and we're going to use these symbols, and these are called inequality symbols. So first off, we got to actually remember what these symbols are. So this symbol here, if we forgot what it is, that's a less than. And then we have this side, which obviously is going to be a greater than. And then we have our equal sign. Okay, so when I start comparing numbers, I need to get them in like similar formats, which means if I can solve them, turn them into a decimal, whatever, I need to have two numbers that are looking very similar before I can compare them. So the square root of 9, I know the square root of 9 is equal to 3, so I'm going to put a 3 there. And then pi, pi I know is about 3.14 ... So then I think, is 3 less than 3.14? Is 3 greater than 3.14? Or is it equal? Well, 3 is going to be less than. So the square root of 9 is less than pi. Okay, number 2. I have the square root of 2. And then I have 1. So square root of 2 is not perfect, but I know that this answer has to be larger than 1, because 1 times 1 is 1. Therefore, the square root of 2 has got to be something a little bit larger than 1. And because of that, we're going to put a greater than symbol. Okay, number 3. We have 0.66 repeating. And then over here I have 2/3. Well, you guys have been taught how to divide, 2 divided by 3, or maybe you just know 2/3 is equal to 0.6 repeating. So I have 0.66 repeating versus 0.6 repeating, but these are really the same thing. This is just the same digits repeating as this one. So these two are equal to each other. Number 4, the square root of 36, we solve that, we know it's 6. And I see 6 versus 6.5. So 6 is less than 6.5. Number 5, the cube root of 343, that's a perfect cube. So hopefully you have that memorized still, and you know that's 7. So 7 is going to be less than 7.2. Number 6, we have the square root of 5 versus 4 here. Okay, so the square root of 5, we know it's between two perfect squares. We have the square root of 4, and then we have the square root of 9. So it's somewhere between those, but obviously it's closer to the 4. Now the square root of 4 is equal to 2, which means the square root of 5 is going to be very close to 2, but just a little bit more than that. But anyway, it's not anywhere near 4, so this has to be less than 4. Alright, 5/10. We know 5/10, that's equal to 0.5 or just 1/2. And the square root of 1 you can solve, you know it's equal to 1. So 0.5 compared to 1, 0.5 is less than 1. And then we have this fraction here, so we have the cube root of 27 over 125. So 27 is a perfect cube. The cube of that is 3. 125 is a perfect cube. The cube of that is 5. So now I have a fraction versus a decimal. Well, I need to get them both in the same form. So 3/5. You can divide 3 by 5, or maybe you just have it memorized now, because this is kind of a benchmark fraction. 3/5 is going to be equal to 0.6. So they're the same numbers. So I put equals. Alright, we're going to turn the page. And we need to look for the page now, just on the back side. It says 7.3a, class activity comparing and ordering real numbers. Alright, in addition, you guys are going to be allowed to use your assignment notebooks. And if you look in your assignment notebook on page 166, so page 166 here. Now, your assignment notebook's got a lot of helpful information and charts in here. But you'll notice that on page 166, it's squares and square roots. It's right next to your multiplication chart. So maybe you've noticed it before, or maybe you just always flip by it and haven't paid attention to it. But if you look here, it says, n squared, 1 times 1 is 1, and the square root of 1 is 1. Just like we know 9 squared is 81, and the square root of 9 is 3. So now we have a nice handy chart here that's going to give us approximation. So these aren't the actual answers because we know that the square root of 2 is going to be an irrational number. But this has been rounded to the nearest hundredth. So 2 squared is 4, but the square root of 2 is very close to 1.41. Okay, so we're going to use this chart here to help us solve the problems on 7.3a. Okay, so I see number 1, the square root of 80. We've got to order these. They want to least to greatest, so it's important to pay attention to direction, smallest to biggest. So square root of 80. So I need to go ahead and look at my chart here. I see, find 80. And I see this square root of 80 is going to be very close to 8.94. So I'm going to come over here, and under square root of 80, I'm going to put it as 8.94. I need to get all of these in a similar format. So I'm going to convert them all to decimals, and then I can start comparing things. Okay, the square root of 62. I'm again looking at my chart, and I see it's like 7.87. Okay, and when I compare things then, I like to think of it as money. So what's the smallest amount of money we have available up here? 8.948, 9, 8.5, or 7.87. Well, 7.87 is the smallest. But instead of writing 7.87, I'm going to write the original number that it was, the square root of 62. Now, as I use it, I'm going to cross it off because that just helps me. Like, hey, I'm done with that. Okay, so then I look for my next number, smallest. I see it's going to be 8. Next smallest I have is 8.5. Then I have 8.94 or 9. Well, 8.94 is the next smallest, so I'm then going to write the square root of 80 because that's what it was, and then I have 9. Okay, so this has been ordered least to greatest. Okay, number 2. Moving down to number 2, we see the square root of negative 13. So looking at my chart again, I see 13 is about 3.61. It is a negative, so I'm going to slap that negative there. Now, all these other numbers are already good to go. They're already in decimal form or they're whole numbers. But what confuses a lot of people when you think least to greatest, you need to put the biggest negative number first. That's the least. If you think of it as money, that's like money you owe. What do you want the least? And that would be negative 4. So negative 4 is the least. Okay, then I look for the next largest negative number. And that's going to be the negative root 13 because it's negative 3.61. So put negative root 13. And then we have negative 3.5. And then last, negative 3. Okay, number 3. We're going to skip down. We're going to go right down to letter A. And it says put the following numbers in order from least to greatest. So the square root of 5. I'm looking at my chart there. I see the square root of 5 is about 2.24. Okay, 5 over 2, that's a fraction right now. I need to convert that to a decimal. Well, 5 divided by 2, you can divide that. Maybe you just know it mentally. It's going to be 2.5. We have 2.2, so that's okay. And the side length of a square with an area of 4. So if I have a square, area 4, they want to know what the side length is. Remember, we do the square root. So the square root of 4 is going to give us 2. Okay, so when I go ahead and I put these in order least to smallest, it looks like this 2 is the smallest one I have. So instead of writing out the side length of a square with an area of 4, I'm just going to put 2 down. And then I see next smallest is 2.2. Next smallest is 2.24. So I'm going to write the square root of 5. And then last we have 2.5. Okay, letter B asks you to find a number between 2.2 and the square root of 5. Well, the square root of 5 we knew was 2.24. Okay, so if I have 2.2 here, and and 2.24. Well, 2.2 only has one digit after the right. If I put a 0 there, maybe it's a little bit easier to think of. So I need to find a number that goes in between like $2.20 and $2.24. So there's a few we can choose. $2.22 it works. Okay, letter C, find an irrational number that's smaller than all the numbers in part A. So if you look at the numbers in part A, 2.24, 2.5, 2. So we need an irrational number. And remember, an irrational number is a decimal that continues on forever with no pattern. So since all these numbers are 2, I'm just going to start off with like a 1. I'm going to put like 1, and then a decimal, and then I'm going to do like 5, 3, 7, 2, 1. So notice I'm writing a decimal that has no pattern to it. 0, 0, 8, 6. I'll put ... so it continues on forever. So in this case, we know that this is an irrational number. It goes on forever, and it is smaller than all those listed. Another example would be, I could put the square root of 2. The square root of 2, if you solve that, that's equal to like 1.41. It just keeps going on forever. So remember, all of our non-perfect squares, they are going to be irrational numbers. Okay, going on to number 4. Put these in order from least to greatest. So square root of 50, if I look at my chart there, I see that's equal to about 7.07. Okay, the square root of 42, we have equal to 6.48. Okay, so now I can go ahead and start ordering these. So the smallest number I see up here is this 6.48. The 6.5, you might be confused. Oh, I'm sorry, I actually see a 6. So the 6 is the smallest. That goes there. And then I have the 6.48, which I should have written the square root of 42. And then I have 6.5. So 6.5 is just a little bit more because that's like $6.50, where this is $6.48. So 6.5. And then next, I see 7. And then last, the square root of 50, because that's about 7.07. Okay, if I find a rational number that's smaller than all the numbers in part A, well, I just got to look at all those and be like, well, these are all around 6, 7, so to find a rational number that's smaller, how about 1? 1 is a rational number, it's smaller than all those. 3, 5, 1/2, 0, negative 2/3. Those are all examples of numbers that are rational that are going to be smaller than that. Irrational. Well, I think I'll probably choose the most famous irrational number there is, and that's going to be pi, because pi is about 3.14. It keeps going on, ... But that's all smaller than 6s and 7s there. Okay, find a number between the square root of 42 and 6.5. So if I consult my chart, square root of 42, we have 6.48 is about, and then 6.5, I think that's like $6.50. So right between that, we got $6.49. Okay, you could also say, well, I'm going to do 6.48 at a 1. So just a little bit more than 6.48, but it's less than 6.5. Okay, so that would work as well. Okay, let's turn the page. Let's go to number 5. Number 5, we're going to jump down to letter A. And once again, we're ordering least to greatest. So square root of 6 we have is equal to 2.45. So here's a decimal, 2.44, 2.4 repeating, 2.5, and the side length of a square with an area of 9. So if you remember back to what we've been talking about, if you have an area, we just take the square root, and then we know the square root of 9 is going to be equal to 3. Okay, so if I put things in least to greatest, I'm seeing 2.44, 2.4 repeating, and 2.5, 2.45. So first up is going to be the 2.44. And then next is going to be 2.4 repeating, because that's 2.4, 4, 4, 4, ... So there's extra that the first number didn't have. So 2.4 repeating. And then After that, I see 2.45. That's going to be the next one because this 5 is bigger than any other 4. Like here's a 4, there's a 4 in the second digit, so that makes that one larger. And 2.45 was equal to the square root of 6. And then I have 2.5. And then last, my square root in the area of 9, so I'm going to just say that one was 3. Okay, find an irrational number that is between 0 and the smallest part from part A. So the smallest part from part A was 2.44. So find an irrational number that's between those. Well, you could start off again and be like 1 point, and then you write a decimal that's going to go on forever that has no pattern to it. 3, 2, 5, 8, 9, 1, 0, 6, ... That's definitely irrational. It's larger than 0, and it's less than 2.44. Okay, find a number that's between 2.44 and the square root of 6. So the square root of 6 is about 2.45. So you see these are very, very close, 2.44 and 2.45. So an easy way is take this first number, write it down, and then just add extra digits onto the end, like a 1, maybe a 2 if you want, or you keep adding more. But so that number is now bigger than this one, but it's less than that one. Okay, that is it for today's lesson.